Greetings, everybody. Welcome once again to another part of our Connection Wednesday series that we hold every second week on Wednesdays, obviously. So, warm welcome to everybody again, and let's take a look. What are we going to do today? Yana, my colleague, is missing today. She's hiking in Nepal on a holiday, so we have let's say, a nice replacement by Lukáš, another colleague from our office. So he'll show you his fine job today. And just about the go-to to mention, not to forget, because you are muted for practical reasons, but don't hesitate. You are very welcome to ask any questions in the question panel. You can write it there and we will answer them during the webinar and after. And if we will have no time answering all of them, you'll get the answers by email later on. So Connection Wednesdays, as you know, probably it's about 30 minutes webinar. We do it twice a day for the European part and the US and Latin America part of the world. And it's every other week, and it's till December 13, the autumn part. So for today, we prepared one customer project that's about a helideck support, this kind of joint. So Lukáš will be presenting you this job. And then about the HelpDesk highlight that we collect on our HelpDesk and process them, help customers to deal with problems. This is one thing about making clear the equilibrium check if to turn it on or off in the load effects and what are the reasons. This is very common question in our help desk, so this is why we want to clarify that. So let's get to the helideck project. This is a project that we got from one of our customers from Italy, who was doing the part of design, the structure analysis of the steel structure. So this helideck is right now under still the design process. It's built by Bayard, and it's a helideck on an offshore structure. So it's made of a aluminium deck and supported by a steel structure, of which part is the steel joint designed in IDEA StatiCa. Diameter of helideck is 23 meters and it's designed for the helicopter Augusta Westland. So that's a very interesting thing. This is a Tekla project drawing of the whole thing. Together the aluminium part and the steel structure below supporting it. And the Italian office is called Studio Dal Ponte Mastioni, and they did the calculation and analysis of the steel structure and all the joints of the steel structure in IDEA StatiCa. Their workflow was let's say the nowadays BIM workflow. So they had the drawing of the project in Tekla structures, then they did the structure analysis in StatPro, and they exported those models into IDEA StatiCa, where they code checked the steel joints. So nice example of a workflow. This is how we would like it to do it. And While the project is still in the design phase, we were not able to collect or to show you and to work with the real data. So we have some restrictions, but we'll do our best to show you as most as we can. So now I'll give a presenter to Lukáš, and he'll tell you more and show you part of the workflow.
Okay, thank you, Adam. I will take a screen. I hope you will see my screen. So, how Adam said, now you can see only the steel truss cantilever, which is composed from the tubes, and I would like to check this joint. How Adam said, I don't have permission to make a process of the export from Tekla structures because the project is still in the process, so we don't have permission for that. So, but we have received a project of the exported joint actually in IDEA. So I will show you the exported geometry of the joint, which is composed from the tube or from the members and from the parts plates. We can say plates. These are I can say stiffening members. Okay, if we have geometry, we need to transfer the load from the upper part of the helideck to the other parts of the tubes, but we need to arrange the load through the stiffening member, which will be added on the upper part of these cross plates. Yes, so I create a new member. You can see the member will be the tube. The diameter of the tube will be 300 millimeters and the thickness 50 millimeters. Now you can see the tube. I will just switch on the transparent view to see the tube, modeling tube, and I change the length of the tube on the 300 millimeters and inclined about 90 degrees. Okay, and the last step, I need to move this tube to the upper part of this cross plate, about 910 millimeters. And I need to change the geometrical type on the endit. Okay. Now you can see I have a stiffening member which will be transfer the load from the helideck to the steel structure, or to the steel joint, which I would like to check. Okay, so now I'm sorry, I will continue to the load effects. And in the load effect, because we have received internal forces from the StatPro, so I will add or import the load cases from the Excel sheet. Here I have, you can see many load cases or load combinations which I would like to I would like to check, but to speeding up, I will pick up only the one. For example, this I'm sorry, only this combination. I'll see this one, and I will perform only copy and paste to this step and give OK. And you can see the internal forces were automatically uploaded from the Excel sheet to the relevant members. Yes. Now I can go immediately to the design, and in the design I need only fix this bottom part of the tube to this cross plate. So I will use manufacturing operation weld or contact. So I would like to make weld in this bottom place. So the member, this is member M6. So I will choose member M6, and the plate. This is the plate SP13. And if I give a transparent view and switch on the butt weld, you can see the weld was created around the circumstance of the tube. Now I have finished the modeling because the operations were automatically exported from Tekla to IDEA. You can see here is many manufacturing operations to this joint, and I can run a nonlinear analysis. It will take a few seconds because it's a difficult type of joint. And now you can see on the first view, you can see a traffic lights. So with the different color on the joint, you can see the utilization of each plates or bolts or welds. To the 60% of the utilization is gray color, to 90% is green color, and over 100% is red color, and we don't have any red color. So in the left part of the window, or in the summary, we can see a summary overview for the plates, welds, and bolts, if they are included, and the utilization. I will continue to the plates, and in the plates we can see the item, material, the strength of the material, thickness of the material, loads which is applied, and the maximal equivalent stress, and plastic strain as well. So I will switch on equivalent stress to see the redistribution of the stress on the joint, and you can see the most subjected part of the joint, which is this part. If I click on it, this tube is wrap out, and you can see the maximal place, or the place with the maximal stress on the tube. Okay, if I switch for another part, she is displayed on the left window, and you can see the redistribution of the stress through the surface. Okay, now I will show you the plastic strain. Here is an area of the plastic strain where is reached the plastic branch. Yes, on the diagram of the steel. So if I switch again to the equivalent stress and turn on the mesh and deform shaped and change the scale, you can see how the joint is deformed. Okay, so now we can proceed to the weld. The welds, every part on this joint, or every weld on this joint, is created from the butt weld. Yes, so it will take a few seconds because there is a many butt welds. So you can see that the equivalent stress or stress perpendicular to the throat is not included because we consider that the butt welds have the same strength of the like the connecting member. Okay. Now I will proceed to the preview print, to the report. Okay, it will take a few seconds. Okay, and here in my report I can set whatever I want. Yes, for example, drawing. Yes, all results for the drawings. So I will make a refresh. It will take a few seconds. Okay, so and now we can go through the report. So you can see the geometry, axonometry of the and some or every view, like front view, side view, type of the cross sections which are involved in this project, and the strength of the material, load effects which are involved, and summary of the check, like for the and each check for the plates and traffic lights, strain, stress on the plates, and the check of the welds. It's a long list of the welds. Yes. Okay, and in the bottom part you can see a bill of material and the shape of the separate components on the joint. And here is only code settings. Yes, I would like to show you, if I will come back to the load effects, I would like to show that we can upload all from the, if I delete this one, and I can upload all 27 combinations from the Excel, only copy and paste, to the load effects. You can see now. I will give OK. It will take a few seconds. Okay. Okay, and now you can see the combinations from the Excel sheets which were uploaded from the ETABS are involved in this step for every member on the joint. Yes. So okay, it's all from my part, and now I will give a presenter to Adam. Adam, you can take presenter.
Yes. All right. So thanks, Lukáš, for your part, and let's get to the HelpDesk highlights part, and let's discuss the check of equilibrium. Right. So I have a very simple example, just a beam bolted to a column through an end plate. And the thing that we are talking about is this check equilibrium, whether to switch it on or off. That's the advanced mode, let's say. So by default, this is switched off, but this is very important thing that everybody should be aware of, because simply said, this should be always switched on, and you should always be aware of having the equilibrium here. So let's get to the explanation. I have 3 project items here for comparison. First one is the, let's say, default or the simple one. Okay, one beam is loaded with a moment and a shear force, and this is very simple. We can check that, calculate the result, see what happens. This is fine. We've calculated with code checks. This joint satisfied the criteria. We are very close to the limit, but still on the safe side. Everything is fine. Good. So this is one option, right? Then if we go back to load effects, and that's actually the second project item, the same example, but now I've turned on the check of equilibrium, and I added some forces in the column that I get from a structure model. We can turn on the wireframe view to see the forces. So this is now assuring that we are calculating the joint also with the transferring forces in the column, right? So we are now also calculating the stresses in the column from the forces that are in the column. So this is all in equilibrium, because this is actually, it has to be in the equilibrium if you have the right results from a structure model. Now let's say the same example as the first one, and if we calculate this now, what we will get is that we didn't satisfy the code check. This is red and it failed the code check, so the design is not fine. So this is that's the difference, and it is obvious only in this examples when the utilization is very close to the limit, but it can affect the outcome of the design or the analysis in IDEA StatiCa. So this is very important to mention, because then when we check the results now, let's say equivalent stress, mesh, and deform shape, we can see the deformation is occurring here in the column as well, and still the column is held on the top and on the bottom, because it's supported somewhere upwards and downwards here. So this is one thing, and then we have sometimes emails on HelpDesk that there is not the equilibrium here, and this is always because of the misunderstanding, because here you implement the nodal forces from this node from the structure model, right? And since you have a structure model that you calculate for various of combinations and load effects, the praxis in some countries is that the structure engineer that designs and checks the joint gets extreme forces from all the combinations all together. So then it's a mixture of each component of the internal forces. So let's, for example, you have a moment around the y-axis from combination 3, then you have a shear force extreme from combination 5, and etc. So then you get one table or one set of forces that you input here in the IDEA StatiCa, and what you get is that it's not balanced, and the code check is also not right, and this is because it's confused. So how it should be done is that you take all the combination, all the load effects, you input them all into IDEA StatiCa and let them all calculate. So you have each of the combination, each of the load effect in equilibrium, and IDEA StatiCa calculates all of them and shows you the overall extreme from all of them. So this is the right way how to do it, and the right way is to check the equilibrium on, because then you're assured that you're also calculating the forces in the supported member. So you avoid underestimating the state of stress and strain in the place of the joint. Okay, then of course you can fix this easily by, for example, adding some stiffeners here. Let's say I have it already calculated. I added some stiffeners, same forces, and I passed the code checks. So the message of this is to always check the equilibrium on and don't confuse forces from various combinations and load effects. Okay, so this is I think all from our side today, and now there is a space for questions and answers. So let's check what all we have here. Okay, there is a question about, let me read that. Why there are no code checks and there are no formulas visible for the welds in the first project?
Okay.
Maybe Lukáš can show you that.
Okay. I will show that.
I'll give you the presenter.
Okay. So I hope you will see my screen, and why you don't see the check for the butt welds? Yes, because the butt welds, like you can see in the manufacturing operations, butt welds you can add here, and you don't have possibility to add the value for the welds, because we consider in our model that the strength of the weld is same like the strength of the connecting material. Yes, so the check is performed for the plates, and for the welds is not included due to this fact that we consider fully welded weld. Yes, if you would like to check the weld, you need to switch on the other type of the weld. It's double fillet weld or one-side fillet weld, and if you input, for example, 5 millimeters, yes, you can see I'm sorry, 5, for example, 10 millimeters. Now you can see that the welds is visible, and you can, if I will run the analysis, so I will go to load effects and delete the load effects to speeding up the calculations. It will take a few seconds. Give me seconds, and I will show you the results for that. Okay, now sorry. Okay, so I need to input the load effects again from my combination. I'll see 90. Okay, only copy paste. So I import the load as like in the previous, and I can go immediately to the check and run the analysis. Yes, and now I hope you will see the check for the welds. Okay, it takes some time. Oh. Okay, now I need to find. Oh, okay. I need to switch off the deformation. Okay, and go through the overview or check. You can see here is a weld, and if I click on the weld, here is a redistribution of the stress around the whole length of the weld, and you can see the equivalent stress. Yes, this is von Mises stress and plastic strain, and for example the stress perpendicular to the throat and stress parallel with the throat and shear stress perpendicular to the throat. And from these three stresses is composed this one equivalent stress. And here you can see the utilization. This is about 99%. Yes, and for this type of welds we have check with our compliance with the Eurocode, and you can see the value here. Yes, I think it's all to the welds, to the explanation of the welds, I hope. So Adam, if you will have another question, can you give me, or I will give you a presenter?
Yes, maybe I can answer one. There is one question about export to DVG.
Export to DVG.
I can maybe show that.
Yes.
There's a question: why can't we export a 3D DVG file from IDEA StatiCa? Yes, we can't do it now. This is under development, so we are working on that currently. It will be available in the future version, so you will directly export DVG from the software. But for now, we've just launched. I'll show you. Switch presenter to me, and let's show you. Go to our web page. We have an online viewer from which you can export to 3D DVG. So you go to our web page, ideastatica.com. You go to cloud. Here we have two things for now: online cloud code check application and online project viewer. This is all for free, and you can here load any project. For example, the one I was showing you. And in this viewer, you can go through all the parts of the joint. You have the drawings here, everything is described. This is very useful for the checkers of design in some countries, and you can browse the whole model, see what everything is there and how is it built, and the thickness of welds, and etc. And here is the function that you can download the 3D DVG, and it just creates the model and you save it wherever, and this is how it works. So it takes a few seconds because it's on our server. And from this, you can then directly open in ACAD software. So if I now browse other questions, okay. Oh, we're right over the time. So I think that's it, and the rest of the questions we will answer by email. There's still some here. So for the conclusion, I thank you very much for your attention today. And just after the webinar, there will be a short survey, just 3 questions for 5 seconds about. The recording of today's session will be placed on the website till tomorrow. And just to mention at the end, our resource center where you can find a lot of things, useful information and projects that you can browse. The recorded webinars that we did before, not only Connection Wednesdays, but we do other as well, also for concrete applications. And the next Connection Wednesday will be in 2 weeks, that's 29th of November. So thank you very much for your attention today, and see you next time. Have a nice day.
Bye-bye.
Bye.